Now in the second part of a YouTube, we are going to show you how to calculate the IP addresses between the links and also fill up the addressing table. Now let's start with a link. So in the previous YouTube, we completed with California 788 host address which was needed. So California, the broadcast address was 192.168.167.255. Now, I'm assuming for our addressing table link, and the first link will be Montreal and Atlanta. So this link between Montreal and Atlanta, will take it as the first link. All right, so first link. We have to calculate the network address, first host, last host, and then broadcast address. And subnet mask. So as you see, Montreal and Atlanta, we have only two host addresses to give. One for the interface of serial 00, one for serial 001. So California, as we saw, it ended with 192.168.167.255. Now here it will be 192.168. It has to be one after this broadcast. 168.0. 192.168, 168.1, 192.168, 168.2, 192.168.168.3, and the subnet mask, because only two host addresses. For links, it's always 255.255.255.252. So this is the IP for my first link. And in my question here, it's Montreal and Atlanta, the first link. Now, just check here. All serial 00 interfaces will take first host address. So we know that the network address is 192.168.168.0. It will be a /30. So the first IP will go to serial 000. First IP is .1. Therefore, here it will be .2. For second link, network address will be 1 after this one. 192.168.168.4. First host, 192.168. 168.5. Last host, 192.168.168.6. Broadcast, 192.168.168.7. And the subnet mask remains the same. Because again, for the second host, second link, Atlanta and Memphis, we have to give only two host addresses. So it remains same, 255.255.255.252. So the network address is 192.168.168.5. .4. It's a /30. Here we have .5, here we have .6. Because I've been told all serial 00 interfaces will take first host address. So this was for the second link. Links refers to the connectivity, to the connection between two routers. Now we are left with Memphis and California, the third link. Third link. So again, network address. It will be 1 after the broadcast here, 192.168.168.8. So this becomes the broadcast address for the network address becomes, so the link between Memphis and California. The network address will be 192.168.168.8. It's a /30. Serial 00 will take the first host address, which is a .9, and the other address comes .10. .11 will be the broadcast address. Last host 192.168.168.10 broadcast. Good. So the subnet mask, since it's a /30, it's again 255.255.255.252. If you want to know how we obtain 255.255.255.252, it's because we require only two host addresses between any links. Only two. One is here, one is for here. So greater or equal to 2, greater equal to 4, n is equal to 2. So only two host bits. So this is like this. Only two host bits are required. Look. So these are my two host bits. So when we calculate all this, it comes to 252. Fill up the addressing table. So we have Atlanta. So first, let's see here. All gigabit interfaces will take first host addresses. So for Atlanta, the first host is 192.168.128.1. So that's how I'm going to fill it. 168.128.1. What was the subnet mask? It's 255.255.224.0. Since it is on the router, so we don't put anything in the default gateway. Now, Atlanta, the serial 00, it's here. So it's .5, 192.168.168.5. It's a /30. The subnet mask for link is 3 times you have 255.255.255.252. So again, since it is on the router, nothing is written in the gateway. Again, for Atlanta, serial 001, here we are. So the network, the IP for this one is 168.168.2. Because it's a serial 001, it took have to fill up the subnet mask. Here it is. Again, it's on the router, we will leave it empty. Now, Memphis gigabit 00. 168.0.1. So you remember we had calculated it here. Then this subnet mask is 255, here it is, .128.0. And again, it's on the router, we don't write anything here. I'm going to fill up 192.168.168.9. 3 times 255. All serial interfaces will have the same subnet mask. Serial 001. It's here. 168.168.6. Again, it's a serial interface. It has the same subnet mask. Good. Next, we have for California to fill up for California. California is 192.168.164.1. Then we have the subnet mask for California, 2 times 255, 252.0. Serial 001. In California, serial 001, it's 192.168.168.8. No, not 10. 3 times 255.252. Okay. So it hasn't given me, as you note here, take note here, it didn't tell me which host address to take on the switch. So I'm going to assume that on S1, this is S1, we are going to take the 5th host address. 5th host address. So this is for Atlanta network. 5th host address would be 192.168.128.5. All right. So this is Atlanta. Atlanta per gigabit had this subnet mask. So it's the same subnet mask because it pertains to the same LAN. Now, one important point here is that switch must have a gateway. All the devices here in the LAN needs a gateway. So how do we get gateway means what? How we get out of a network to access other networks. So whether PC1, whether PC2 or the switch, they all have to pass through gigabit 000 of Atlanta. For this reason, it becomes the gateway here. This IP address, gigabit 00, have this IP address, and this becomes the gateway to the switch. Because S1 has to go through here to get out of the network. Now, PC1, a workstation. Now let's see what the question tells us. All odd numbered workstation will take second host address. This is an odd number 1. This is an even number. So we are going to take the second host address. So it's .2. And even numbered will take 10th host address. This will be .10. Okay, so PC1 is going to have 192.168.128.2. It's again in Atlanta, network of Atlanta. So the same subnet mask. The gateway is same as the switch because they form part of the same network. PC2 also forms part of a network where we have S1 and PC1. This means that the subnet mask and gateway will be same. All right. Now PC2 is having the 10th host address. For these reasons, it is .10. Now for PC3 now. Here it's PC3. It's all odd numbered workstation will take second host address. So in this case, it's not here, it's .2. Here, even number takes 10th, so .10. So PC3 192.168.0.2. 3 is in the same network as the LAN of Memphis. So Memphis has got 255.128.0. Now the gateway for PC3, it has to see where is the router, but it has to access. It's Memphis. So it has to go through this interface, gigabit 00. So this becomes a gateway for this switch, for this PC3 and PC4. So here the gateway would be 198.168.0.1. PC4 is in the same network, so the gateway is same, the subnet mask is same. Now it's an even number, it's .10, 192.168.0.10. Now PC5 is in California network. So PC5 here is an odd numbered PC workstation. All odd number, we take second host address. Again, it's will be 0.2. 192.168.164.2. 255, California. It's 252.0. Then we have PC6 here. Even numbered workstation. So it's 10th host address, 160.10. So it's Montreal gigabit 00. Montreal, this is the 10th host address. Now let's see what was the subnet mask. It's 255.252.0, and the gateway is Montreal, it will be the first host address here, 160.1. Because 160.1 will be the first host address we're going to put here, .1. So since the addressing table didn't require you to enter for Montreal, so that's why it's not in it. Else we could have added Montreal gigabit 00 and 000. Montreal is not in the addressing table, so we don't have to fill up the IP addresses of Montreal. And by now you should understand how you can calculate VLSM and how to fill up addressing table, whether it's for links, IP addresses for links, or for LANs. Thank you.